So let's look at the solution to our consistency quiz, where we have coherent memory, but an out-of-order pair of cores, where branches are predicted, stores are still done strictly in program order, but loads can be reordered, and these two variables start at 0. What the programmer is kind of expected to happen is that I put some values in some data, then I set a flag, and the other core waits for that flag to be set so that it can print the data that I produced. So in program order, the only thing that can really happen is that we print 15. In the execution order, that can also happen. If this core gets to this part before we even start checking, we might compute 15 in the data, set flag to 1, core 1, loops here, sees that the flag is 1, exits, prints 15. So clearly 15 is possible. But the question is, can we get anything else? These are done strictly in order, so if anything else does get printed, it's not going to be because this core did the data write after the flag was set. The flag actually gets set after the writes are complete. But here's what can happen. This loop here amounts to reading the flag, testing if it's 0, and then branching based on that. This processor can easily predict this branch in a way that says we exit before it even gets to check what the flag was. So at that point we will be here, and we will fetch the data to be printed. The data at that point might be 0. So what we do is we predict it goes out, and we fetch the data at this point. So it's kind of step 1, predict and leave the loop. Step 2, read the data, and it's 0 at this point. Then let's say core 2 finishes this, and at that point this out-of-order processor does this load. Remember, these are loads, they can be reordered. If we do this, we see that the flag at this point is 1, so our prediction was correct, and at this point we can print the data that we found. In this case, we will print 0. A similar outcome is possible for data equals 10 simply by moving this here. So we can also print 10 if access number 2, which reads the data after the prediction of the branch, happens here. And finally, we could get 15 in the data if we get it here, but we already knew we could get 15. Note that it's not possible to get 5 or anything else. And the reason is that these writes on the same core will happen in program order. It's incorrect for a core to somehow read 0 here, because the only way we read data here is if it was already written here. On the same core, we have to obey the program order. That was never in question. So the data, when it's read here, has to be 10. We can only increment it by 5 to 15. We cannot read 0 here. So that's why it's possible only to get 0, 10, or 15. So basically the real problem is that somehow, although we thought we are waiting for the flag to be set before we access the data, in reality we managed to access the data at kind of any point before the flag was set, and coherence again didn't prevent this. What we need is consistency.